Welcome everyone to Raven Build V1.0. We're very happy to have Moritz here today teaching this kind of revolutionary plugin, which is kind of changing the way that you'll work and is giving us kind of, in my opinion, the first glimpse of the future of these workflows. Um, and so in this webinar, we'll be using their plugin, which is Raven for Grasshopper, which is an AI assistant for Grasshopper directly in Grasshopper, which can make networks for you, make designs for you, and all kinds of fun stuff that you'll see. Um, so Moritz is a co-founder of Raven, building at the frontier of AI capabilities in CAD. His work builds on research at UC Berkeley from early 2024, bringing early LLMs into CAD as AI collaborative tools with Professor Kyle Steinfeld and robotic fabrication with Professor Simon Schleicher. Morse has lectured internationally on AI-based creative tools, published at Acadia and the IJAC Journal, hosted workshops at MIT and Tongji, and contributed to international research conferences. And their tool and company, Raven, is a Grasshopper native AI that writes scripts, edits existing ones, and interfaces with your plugins, empowering your workflow. Yeah, very excited to start this. And before I pass it over to, let me stop sharing. Before I pass it over, just a reminder for everyone here, if you want to use the chat, please switch your chat to say everyone. I believe at the beginning it's just saying hosts and panelists. So switch that to everyone so we can all participate in the discussion. So now I'll hand it over to you, Moritz.
Awesome. Great. Thank you very much. Yeah, I'm looking forward to this, and I have a presentation that I'm going to run you guys through first, and then we'll jump in to work with Raven. So great to see we already have 65 people. So let's kick this off.
Yeah, and many, many more signed up.
Yeah,
But maybe they're still sleeping.
it's a good. I was having this discussion actually. It's an interesting time. If you have to pick a time that works for as many people as possible.
Yeah, exactly.
All right, so I'm gonna first of all show you give us like a little bit of an overview, like what is behind Raven, how did we get here, what was maybe the research that went into it also, and then we'll all together like set up Raven, and you'll get a workshop license. So for the duration of this workshop, you're not gonna hit any limits or anything like that. I think that'll be great. So that's what we're gonna be doing, and then these are the times in like this universal time. So for me, it's 2 hours later, but kickoff would be now. Then I'm gonna do my lecture on sort of what's behind it, what are the thoughts behind it. Also, we'll set all this up. I put in a little break here. I might need to do more breaks than that because it's really hot where I am, so I might need a water break in between. But let's see, and then we'll have some advanced workflows I want to show you. And by the end of it, you should really have a thorough grasp on what Raven can do and how you can really effectively leverage it in your own workflows, and use it to learn any new plugin that you're interested in or new workflows, or get over that fear of someone else's Grasshopper script, or even just getting started with parametric design. So yeah, I'll kick it right off. You already mentioned it, but I started my work in this field more than 2 years ago. Back then, LLMs were very, very different from today's LLMs. So a lot of the work went into how, like, is it even possible to create CAD models with LLMs, and how do you like elicit the right kind of behavior out of this very basic next token prediction LLM that can write text, but that's kind of it. Um, and today, of course, we're in a very different world. So there's like this whole journey from very, very early versions that were very hacky, and we had to do a lot of like special strategies to sort of get the behavior out of the LLM that you wanted, to today's LLMs that are just so much better in every aspect when it comes to CAD, which also makes Raven, of course, much better, which is great. So the idea of my first paper, it was called Mediating Modes of Thought. And it goes back to this observation that I had when I was in school, across industrial design, architecture, and many other fields that are using, advanced CAD tools. There's a split between the more designer people and then the computational people. Even if they're still designers, computational designers work very, very differently from everybody else in the field, and they're just a small subset. Despite the computational tools being useful for many more people, right? So it's usually like a training, upskilling problem, and not that the computational tools are not useful. A lot of times, computational tools could save a lot of time in practice, and enable you to do more in-house or on your own without like external experts. But there's just this huge barrier. So I was thinking about this for a while because I had a lot of people around me who didn't know how to use Grasshopper or anything like that, and were sort of stuck in the manual CAD world. And I figured that there's the big split is that the computational tools, they are very, very deterministic and structured. They require you to like explicitly state and create the algorithm, whether that be in programming code or in Grasshopper nodes. It still has to be very explicit, and kind of absolute. It doesn't have room for ambiguity. Um, Unlike a lot of design work, where even if you're pushing boxes around in Rhino, or even better, you're sketching, there is a lot of ambiguity. You don't really have to make all the decisions just yet. You don't have to set a fixed value for the width of your building from the start. You can just kind of, add a box and then move it and push and pull it around. So there's a lot less structuredness in there, and the two don't mix. So people who use Grasshopper have to be very structured, and the people who don't use Grasshopper are very unstructured. So it's very difficult to get the unstructured people, or like modes of thinking and sort of creative exploration into this more structured tools. So I thought LLMs are a super interesting place for this because they combine sort of they understand a lot of fuzziness. So when you show them sketches or you speak language, you don't have to be so structured and deterministic. You don't have to sort of predefine everything, because LLM can take your natural language input and turn it into a structured Grasshopper format or something like that, right? So it can kind of mediate between the two modes of thinking and allow you to maybe express ideas more roughly and have the LLM make intelligent guesses to sort of fill in the blanks in between and then create a working Grasshopper file. So I thought that was a very interesting capability, and I thought it would be a great way to bring more people into the computational tools because it sort of mediates this chasm between the two. So that was the idea, mediating modes of thought, and that was the very first paper. At the time, had quite a complex setup. I'm just going to run through this fairly quickly because it's outdated now, but it still helps to understand why the thing that we do with Raven even works. So we basically had three sub-agents. Today, sub-agents are very different from back then. So at the time, that just meant three different LLM calls. And the first one would be just taking the user prompt, so something like an umbrella, and asking the agent to describe in natural language what that shape looks like. So I figured since the agent can tell me, oh, an umbrella is made up like of a central pole and a canopy, this natural language description shows that it has some, I don't want to say understanding, but idea of the shape of an umbrella. So how do I extract this idea and put it into CAD, right? If it's able to describe different aspects of the shape, then maybe it is able to describe them in a way that we can then set up a Grasshopper file or whatever, some other CAD structure for it. So the very first agent would just talk about this shape. So this is what that looked like. It would say, okay, the user said an umbrella. So the goal is to create a parametric model of an umbrella, which looks like a canopy and the central pole. And then it would say, okay, so looking at an umbrella, there are just certain values that are relevant. So the canopy radius is one of them. How tall is the umbrella? How wide is it? How big is the pole? Like what's the radius of the pole? And it would just in natural language sort of talk about the umbrella and say, well, this is what the shape looks like. And then these are sort of relevant values that make up, characterize maybe the umbrella. And then it would just speak. So this has nothing to do with Grasshopper yet. You just say, well, to map from these inputs that I've just defined, like the relevant values, to this final geometry that I described, here's what you would do. And then it would write down these logic steps. So create a point, and the circle around that point that you extrude. Then you take another circle and divide it into points, which become your umbrella legs and so on. So it would just talk about it. That would be the first agent. And then I would take that description, that language description, and ask another agent to take a list of Grasshopper components that I predefined as being available and look at the logic that the other agent wrote and chain together Grasshopper components to sort of copy that logic, right? So create a point at the origin, and you have to know, okay, there's a construct point component, let's use that one, and then let's use the circle component, and then let's use the extrude component. Just mapping the logic that is described to the Grasshopper components. And then the third agent would just take that and turn it into a very structured format, so you could parse it with an automatic system, right? So going from the very fuzzy prompt and umbrella, sort of trickling through to more and more deterministic structure. And at the end, having a JSON file that you can just parse. So there were three LLM calls involved, and it would just get less fuzzy and more specific at each step. And then this would be the result. So you can see you kind of get it. It's an umbrella, but the canopy is on the wrong place. So the move component didn't work. But all in all, it's pretty good. You can see it kind of makes sense. It kind of is able to create an umbrella based on the prompt. But it takes really long, and it takes 3 different LLMs that you have to ask. So, and also I had to run it a few times to get this result. So this was like the best result I could get at the time, 2 years ago. Exactly. And then as soon as you ask for something more complex, like a suspension bridge, it would just, I don't know, give you some random result. So this was also the best result I could obtain in like 10 retries for a suspension bridge, because you can kind of see that the idea of a catenary cable is there, even though it's upside down. So this is like the closest I could get to something that you might consider a bridge. So this was 2 years ago, very early for the LLM age. And then since then, actually in the same year, end of 2024, the first reasoning model dropped. And it was called O1 Preview. It was an OpenAI model at the time. And immediately I could scrap all of my different agents and just call that model, and it would do all of the work that I just walked you through internally. So in the inner reasoning talk, it would do like, oh, what is the user trying to achieve? Oh, okay, he's trying to create a 3D model. What does the 3D model shape look like? And then what are relevant inputs? And how do you map from the inputs to the outputs? And what are available Grasshopper components? And then it would chain them all up. So it was a huge leap. The reasoning models made all the difference for LLMs in CAD. And by the time I presented the paper, so the paper was kept at the conference, by the time I presented it, this is what I could show. That you can go from a sketch, put it into, a very early version of Raven, and it would think for quite a while, and then it would return this. So I thought that was quite incredible. Of course, it's interesting to think why does that work? Why does it work so well? And how do you kind of build with LLMs knowing that they're still limited, right? So one of the big problems, for example, how do you avoid hallucinations? How do you let the LLM work with like geometry that actually functions, components that actually exist, and operations that make sense, and sort of avoid or mediate the hallucinations that it comes up with. So that's like this like $1 billion question, right? But I like to explore it a little bit with you guys, because it will help you understand how the tool works and what it's good at and maybe not so good at it, and why, like, so what's the functioning of it. So it's kind of this idea that you go from a slot machine that's always a little bit different and sort of unpredictable and can hallucinate, to something that's more of a magic wand or like a useful tool that still has the AI capability in it. Because of course hallucinations suck, but at the same time, hallucinations can be super useful because they're a part of like creative solutions, right? Creative problem solving requires you to come up with sort of unexpected things. So hallucinations are not per se bad, or like they are bad themselves, but they also point to a characteristic that is useful. So you don't want to become a completely structured and deterministic LLM. You want to keep some of that creative flow. So it's the reason why the O1 preview model made such a big difference is that it's a reasoning model. And by now, most of the LLMs you interact with probably do this thinking, where they just like think for a while before responding, and then they give you an answer. And that makes all the difference, because LLMs used to just predict the next token, like the next bit of word, the next text letter, based on the text that came before from learning everything on the internet. And that's what the first ChatGPT was. So it would just babble, right? Which is interesting, but the reasoning models are very, very different. So what happened is instead of just training on the internet, basically what they did is they took that like that trained LLM, and they gave it math questions. So LLMs used to be famously bad at math. They could not do any calculations, even like simple stuff, counting R's in a strawberry, and so on. All of those things got it wrong. But now what they would do is they would ask it math questions that they knew the answer to, and then when it got the answer correct, they would say, okay. Oh wait, actually, well, I'm getting ahead of myself, but it would be forced to do some talking, internal talking, and then give a response instead of just answering the math question. And the internal talking is what today we call reasoning. And so that inner monologue would be considered useful if the response was correct. So if your inner monologue leads to the correct math result, you're probably doing reasoning. So we're going to fine tune on that. So we'll keep that inner monologue and like sort of reinforce it and have the model think more like that. And if your inner monologue doesn't lead to the right math result, we'll discard it. And that's at the core sort of what a reasoning model is. And they did that for math questions, and then they released O1 preview, and it made all the difference in Grasshopper because geometry is just a subset of math. So if you get the right sort of logical reasoning chains going in that internal monologue, it can not just solve math problems, but it also maps to Grasshopper and geometry. So the LLMs training on math. Nowadays, they're training on much more, but they used to just train on math. Now, of course, a lot of it is coding, but also other domains. And it maps like this capability of thorough reasoning maps really well to geometry and CAD as well. So that is one way to get more truthful LLMs that are better at something like math that they used to suck at. There's other things too. Like what we do at Raven, we call it a neurosymbolic system. So the idea is that the language model doesn't construct the entire CAD model, but it basically makes a plan, right? So Raven, well, Raven is the whole system, but the LLM comes up with a plan on like a Grasshopper model it wants to make. And instead of making this entire plan and giving you the final model, what it does is it makes a plan and it sends it to Grasshopper. Then in Grasshopper, the model is assembled, so all the components are connected and so on. And then feedback is sort of aggregated. So do those components exist? Do they connect correctly? Are there any errors that are coming up? What is sort of the output, the geometry? What does it result in? And so on. All of this feedback is collected and then returned to the model. And the model can iterate over it. So instead of having to come up with a really complex model in one go, it can actually build it up bit by bit. And every time it gets something wrong, like it's trying to use a component that doesn't exist, or it connects components in the wrong way, it gets that as feedback and it just corrects it in the next pass. So in this way, it iterates over the problem instead of having to solve it in one go. And every time it iterates, its hallucinations are corrected. It's reminded, hey, this component doesn't exist. It's reminded that these connections are faulty and so on. So this iteration is sort of a self-healing process, and you'll see it in action in Raven. This is also inspired by other people's research, but I'm just going to show you a video that exemplifies it. So remember before, when you asked for a suspension bridge, it would go through 3 different agents and just give you something, and then you're done with it, and it was really bad. But with reasoning models and with the self-healing, you see that Raven doesn't just create the whole bridge in one go. Like this is what you get nowadays for model the Golden Gate Bridge. We probably get even better models today. This was also already a few months ago. And you see that Raven creates something and then adds to it and then adds to it, and every time it's correcting errors as well. So this way, it doesn't have to get everything correct the first time because it can just fix things in the next pass. There's also points to a really, really exciting, sort of more out there idea where because Raven is using the CAD system as a sort of validator, so it's just writing a plan and then the Grasshopper kernel is executing it. So all of the math still happens in Rhino and Grasshopper, which makes it an interesting situation where Raven might come up and try out 100 different structures, for example, for a bridge. And it doesn't have to calculate the load or like how structurally sound they are because it can offload that to a Karamba simulation. So you can imagine having a bridge set up and then just saying, hey, Raven, try to come up with a better performing structure of my like given bridge and Karamba simulation, and Raven can just go and try out 100 or 1,000 different bridges, um, and always checking them against the Karamba simulation, and finding like an even better performing bridge than you might have been able to come up with, just because it can search in a space that is validated by the Karamba bridge, which is similar to some work that happens at Google and also, of course, at Anthropic and OpenAI, where they use LLMs to basically improve code autonomously. So the LLM rewrites code and then runs it to check how efficient the code is. So this is for like really big distributed systems or something, very complex problems that are hard to solve optimally, or there's no optimal solution, or it's very hard to find. So you have the LLM change the code and see if it's better, and change it again and see if it's better. And this way, every time it's better, you keep the change, and every time it's worse, you discard it. So you can really find new ways to efficiency if you have an easy way to evaluate whether something is worse or not. And then the third sort of core idea that we've built into Raven is that everything works on node basis. So Grasshopper is already like this, and that's why we went into Grasshopper, because actually hidden behind the node interface, there's everything from CAD functions to running a simulation with Kangaroo or Karamba, drawing in data, pushing out data, calling for an APIs that would be like Rhino inside Revit or Tekla structures or anything like this, or just writing a bit of code. All of those things happen inside of a node, which is very exciting because all we have to do is figure out how Raven can connect to different nodes, and everything that's inside of the node is already handled by the existing system. So Raven can immediately start working with all of the plugins as long as it can work with the node inputs and output connections. And nodes come with semantics. So nodes have input and output descriptions and so on, which makes it very easy for an LLM to understand what the purpose of a node is. And nodes are structured. So if you make a model with Raven, you can create groups, and you can create clusters and subgroups and subclusters and so on. And over time, you can build very complex models that are very well structured parametric models. Instead of, for example, when you use an MCP, you make a model in Rhino, and it will just create boxes that are kind of like in space, right? It will just create a 3D model. You ask for a house, and it will just make a house, and then you're kind of stuck with the house. So if you go in and like manually change the house again, whereas with if you make a model with Raven, you will get a very structured graph, which then when you want to make a change to it, it's a lot easier for the AI to like go in, look around the graph and find the right nodes to change than if you have to just look at boxes and figure out their purpose from their position in space or something like that. You have to figure out that this is actually a floor plate because of its size and where it's located, instead of having it sort of logically derived from the structure. And then you can collapse the groups and so on. Okay, so we think Grasshopper is a really nice interface to work with AI, maybe the best interface to work with AI in CAD, because it doesn't give you just an output, right? A lot of the times when you, for example, think of an image generation model, at least in the past, it would be you prompt something and then you get an image. And if you don't like something about the image, it used to be you have to go back to the text and change your text, adjust your text prompt to get a different image. But a text prompt could be displayed in 1,000 different images, but you cannot interact with the actual image. Instead, you have to work with the words only. Same thing is true when you have a mesh generation AI, for example. You go from a couple words, you're given a mesh, and then you cannot go in and like change a part of the mesh because you're not in. It's not a Rhino model. It's just like a final output in a way. So you have to go back and like rerun the model from scratch to create a different mesh. Whereas with Raven, what you get is it's very different. You get a workflow, right? So it's not just, hey, here's your geometry output. Instead, it's like, here's a logic that constructs this geometry output, and it's exposed to you, so you can see the algorithm that makes the thing, and you're also shown all of the inputs. So it's kind of an invitation to be like, hey, Raven, make something, and then Raven shows you not the geometry result, but the process to achieve that geometry result, and you're invited to come in and change things. So it's like, okay, make my building, and then you're like, okay, here's my workflow, and then you can come in and say, oh, actually, I need to change the building height. I want to add an extra floor. I want to change the base shape, and all those things are super like Grasshopper is built as an interface for humans, right? So it's built in a way that you can come in and change things, and you're sort of invited to do so instead of having to go back and just prompt Raven. So you're not stuck with just text interactions, but instead you have like the native Grasshopper components as well, and have just as much control as you had before AI, but you also have AI. So it's like a collaboration instead of sort of banning you to just the chat window and not being able to like actively interact with things. So those are like maybe the four most important things. Canvas is Grasshopper is collaborative canvas. The nodes are sort of a scalable interface to anything that you might want to do in CAD software. And the grounding in existing reliable tools. So we're using Grasshopper kernel, the Grasshopper kernel that we know works well instead of having the LLM basically come up with the entire calculation. And this mix of being able to have ambiguous input be converted into more structured input. So that was my background in kind of the research. Now I'm going to show you more of the actual product, what it can do, and some capabilities. Before I'll go into the setup, I just want to have a quick check if everything's looking good because I um, can't see the chat when I'm talking, but it looks good. I think everybody can still hear me. Okay. Perfect. So I'll continue. I think right now is a very interesting time for AI and CAD, especially. And of course, AI is everywhere, and maybe everybody's already sick of it. But to be honest, in the work that we do in computational design, it is not that prominent yet, and it's just kind of starting. Whereas, for example, in image generation, so if you used to do renderings for architects, that has completely changed, right? Over the last 3 to 4 years, AI image generation has been adopted everywhere to an insane degree, if you ask me. I mean, I've talked to people that um, they don't they do a lot of the like options that they offer to a client just from prompting LLMs nowadays. So they just prompt Nano Banana to do like options of architecture, and only once a client has picked something do they go and model it. Whereas I mean, mesh generation is also really, really good, but we talked about the fact that you're sort of stuck with the mesh, right? So you can create really good meshes using AI, but meshes don't invite you to continue working on them. So you're sort of stuck with like finding a different image or going back to your prompt. Um, exactly. And what we could also see is there's a lot of new software being built that are like web-based CAD platforms. Some of them are specific to like being AI native. Some of them are specific to a certain workflow. So maybe like building units or something like that. But we also think that we take issue with it because it's kind of this idea that you have to rebuild everything from scratch just because AI exists nowadays. While the reality is that everybody already has tools that they trust and love, and we instead like opt to bring AI to those existing tools. That's why we're the Rhino and Grasshopper AI. That's what we really believe in. We're convinced that this community of people building their own plugins, building stuff on top of Rhino Grasshopper, it being this very open and interoperable platform that works with everything. That's probably the best thing to bet on in the AI age, where vibe coding, snippets of code, building on top of and hacking existing software becomes so much more useful, right? And if you're building on a closed platform, let's say maybe an Autodesk product, you're going to be stuck with only the things that Autodesk wants you to hack, whereas Rhino and Grasshopper are sort of all the APIs are exposed. You can do whatever you want, and therefore you can achieve so many more things using AI encoding and tools like Raven, right? And so instead of saying we're building an AI CAD suite, we decided to take the best CAD suite that we know and build the AI part on top of it. So we can build a lot more AI capabilities because we don't have to build the CAD capabilities. And yeah, actually, I'm going to skip this one. And that also means in Raven in Rhino that we work with all of the existing other tools other people have built. So this big community that includes structural analysis tools, like Karamba, Shapediver to like host things on the web, the bridges to other tools like Revit or ArchiCAD. All of those things already exist in Rhino, and we can just add the AI, like we can make use of them with our AI. So we can offer you an AI that can do so much more because we're building with the community instead of like going to build like an isolated thing on its own. And so the core beliefs that we've sort of built into Raven is it's not about like generating a pretty image or a mesh or something. It's really about the workflow and being like deeply embedded in your workflow. Uh, Core to that is that you don't prompt a building. I don't think you will ever prompt a building to just say like, oh, make a house and get a house, because it won't be relevant to your context and to your to the thing that you're working on. Also, we're not even specific to AEC, so same is true for our footwear customers, our industrial designers, jewelry designers, boat designers, engineers, structural engineers. They're not going to prompt the entire project. They will use AI to get the thing that they want, not like some AI generated building, right? So we really care about sort of the agency of helping you get the thing that you were looking for instead of taking your agency out of the equation and just giving you a result, which takes a lot of iteration, right? I mean, you iterate a lot today already. It's just like you should probably iterate a lot more instead of sitting there and clicking a lot. It would be, I think, much better to get results faster so you can iterate over them and make better designs, make better projects that perform better. So that's our goal, and that's why we work also with all the existing tools that already are out there. Now, I actually have a different thing I wanted to show. So let me just pull that up. Okay, because so this version of the presentation has some cool demos that I can't wait to share. So the idea that we have for Raven is that using the existing platforms, it can help you connect all the tools that you already use, right? Bringing sort of AI into that equation. So your company already uses Ladybug, but you might have only a couple of experts that can use it, and now you can multiply those experts, and everybody in the team can get help from it. Or maybe you're an individual and you're using ArchiCAD at work, and you're interested in Rhino and Grasshopper, but you didn't even know that to connect. And with Raven and the ArchiCAD bridge, you can now like build your stuff in Rhino and Grasshopper and bring it all into native ArchiCAD geometry. And you don't need to learn the ArchiCAD bridge plugin anymore. So this is a workflow that we like to show. You can sketch. So here we go. It's very ambiguous. It's loose. It's early stage. It's not very structured. So it usually wouldn't be a Grasshopper problem. But now with Raven, you get you say voxelized tower. You get a start, and then you say, okay, now we need this. Now we need that, and you can iterate together with Raven and build a fairly complex Grasshopper model of this like voxelized tower. You can draw on the screenshot, say, hey, please subdivide the facade like this. Please add these balconies and so on. It's really fast. I mean, building this a tower like this in Grasshopper would have taken really long before, and now it's literally like sketching, drawing, super loose, early exploring, getting you to just like try stuff out, right? You don't have to try it all out on paper and then only go into Grasshopper at the end, but instead you can be in Grasshopper first and always build everything that you do parametric. This is the kind of workflow that we see a lot of people adopt if they're in architecture, which I know a lot of my demos are very architecture specific, but I promise you, half of our users have nothing to do with architecture. So all of this also applies to you if you're doing footwear, if you're doing jewelry, if you're a structural engineer and you need to make a structural model for a building. So we're gonna run through a similar workflow like this, which I'm excited about. Another key part of having Raven inside of your Grasshopper means that when you open up a script, any script with any plugin in it from anybody, it can be downloaded from the internet, it can be part of Design Morphine's master program, it can be something that some Grasshopper wizard at your firm came up with, anything. If you open it and you ask Raven about it, Raven will look through that script and it will respond to you based on this script and the current state of it. You can say, explain the script to me. You can select a component, say, hey, what does this component do? You can say, hey, can you show me the part of the script where, I don't know, the subdivision of the facade happens, and it will zoom into that part of the script. You can say, yeah, really anything. You can have a Karamba simulation ready, and you can say, "Oh, help me evaluate whether my structure performs well or not." And you can have this conversation, and you can have these conversations with other LLMs, right? You can have a ChatGPT conversation about it, but it's not grounded, it's not based on your actual document. So if you ask Raven a question, it will go through the file, it will look at the data inputs and outputs, and it will look at the deflection that your structure in Karamba has, and it will talk about that instead of requiring you to basically bring all that info in at firsthand. And then Raven can also help you explore different variations. So say, oh, actually, I want a different structure. Maybe the truss should be half as large, and then like no cross connections. And Raven can help you make those changes and then reevaluate. So in this case, we also have an ask mode, which basically blocks Raven from making any changes, and you can just talk about the script. Get help also. If you're actually looking to learn Grasshopper, you can put in ask mode and just have Raven kind of guide you to through the script. When you get stuck, you can ask a question, stuff like that. And then this is
so we can use that one directly.
This is my Karamba example. So I have a very simple truss bridge ready. It's being simulated. You can see the stresses in the beams. And then I'm asking, oh, can we switch it for a different beam? Then Raven switches it. Cross-section name to beam. Oops.
So we can use that.
I ask, okay, what's the displacement that we have, like the maximum point? Is that like fine? And this entire conversation is based on the structural analysis and not like a hallucination. So again, LLMs can hallucinate, but if you ground them with reliable tools like Rhino Grasshopper, like Karamba, they are extremely useful because when they have the wrong assumption, it sort of gets corrected by the actual tool that's sort of doing the calculations. And then I've already mentioned it a couple of times, but you can use the Rhino inside Revit bridge also for like this. This is just a simple, maybe playful idea, but here Max from our team, he's building a house in Revit, right, with like doors and everything and a simple floor plan, just by chatting with Raven. And Raven will build it in Grasshopper geometry and then hook it up into native Revit components using Rhino inside Revit. Super cool. And the same is true for ArchiCAD. So depending on where you are located geographically, or even just within one country, it's very, very split between ArchiCAD and Revit. So the same is true for ArchiCAD in this case. Fairly simple office massing, and then it gets pushed into native ArchiCAD geometry. You can see with the right facade tonalization already applied, it's all like a BIM object from there on out. And you can make changes, and the ArchiCAD bridge will update them in ArchiCAD. Now, before we jump in, I'm going to show you a little bit of the future as well, because of course at Raven, we want to make the best tools to use AI in your CAD workflows. That's who we are. And we're thinking a lot about the best ways to sort of give you the control and sort of keep you in the authorship position. And at the same time, sort of putting AI maybe on leash, but also sort of leveraging the full power of it. And one thing that I found inspiring in this way at the start of the year, I thought a lot about the Blender modifier. So if you're not familiar with Blender, in Blender, you can have an object and then apply a bit of logic to it. For example, a subdivision modifier, which will just smooth all of the edges. So if you're familiar with sub D, you know that you have this sort of very clunky, boxy version of sub D, and then you can smoothen it, right? And so in Blender, for example, you can have an object, you can apply a smoothing mask to it, then you can like maybe thicken it, so instead of being a thin surface, it becomes like a 3D geometry. And all of these things are like little tabs on the object. So they're not a Grasshopper file that you have to open and you have programmed the entire thing in one Grasshopper file, but instead you click on an object and then you say this object should now get this snippet of logic or this snippet of logic. And so that's why we built a project called Grasshopper Modifiers, which this is going to be the demo of. And you can see when you click on an object, now there's a new modifier tab that opens up in the top right. And some of the icons, we've already changed by now, so this demo is a bit out of date, but it allows you to select from a drop-down a Grasshopper file. So if you look at this, it says, there's a bunch of different Grasshopper files, very simple ones, move, taper, subdivide, and so on. And you can select one. And then the object in your viewport, see, it changes. So you have the original box as a wireframe, and the taper logic is applied. And so the box now is tapered, and that's what you see. So you basically have a control box that you can still move around, but what you actually see, the object has a taper applied to it, which is kind of like a minimal Grasshopper script. But where it gets interesting is that now you can click on it and add, you see, basically you can open it up and you can get UI controls for this taper, but you can also add another Grasshopper file to it. So in this case, I'm doing a solid difference. So I'm trying to cut through the building geometry. So I select another object and then so you see it's cutting through. So our original box is now run through the taper. And then the result of the taper is run through the solid difference. And now I've cut it into floor plates. So, and if I change the box that we started out with, all of the logic gets applied again and it updates. So here I now have basically a box that controls my model. So it's like referencing a box in Grasshopper. And you could have, made one Grasshopper script that does all of this. But this way, it's much more maintainable because I just know like, oh, I'm going to be tapering things every now and then. So I just save one small Grasshopper script that tapers objects, and then one small Grasshopper script that cuts them into floor plates. And here you see this entire building is now just basically a cascade of Grasshopper scripts. So first this, then that, then that, then that. All of these get executed. One of them is even a ladybug script that calculates a daylight factor on the floor plates. And they all they're executed sequentially, and they all have a little UI, so you can change, like how big are the diamonds of the facade and all of these little things. But you don't have to be in Grasshopper. So you can imagine it gives you a lot of the logic and the power of Grasshopper without having to basically live in the spaghetti. So we think that Grasshopper is an amazing tool, and a lot of the times you want to be exposed to the entire logic graph and Grasshopper. But sometimes, especially if you're not used to computational design and you're doing a lot more basic design work, you don't want that. What you want is to stay within your Rhino viewport and just get the power of Grasshopper sort of in the background, which is why we built this modifier project. And that's kind of the philosophy behind it. At the same time, you can always select the object and then look at the modifier tab and click on this little edit button, and it will bring up here. So I'm clicking on the edit button, and it will bring up the Grasshopper file behind it, so you can change it, right? So it's still just Grasshopper. So you're still fully in control. There's a very simple way to define inputs and outputs, and the UI, like the number sliders, that should be in the UI. But it's just a Grasshopper file. So you can imagine if you're working in a team with other people, you might have a couple experts building out the modifiers, and everybody else can just like use them with the little UI, right? So now instead of having this twisting tower in one Grasshopper script, I have a bunch of little ones that are much easier to maintain and also control. So that's what we're building in the future, and it's also something that we're building with the community. So this is actually an open source project. If you're interested in this, I think we'll launch it. We'll release because we rebuilt it. It was a hackathon project originally, so then we've rebuilt it from scratch, together with a collaborator, and we're going to release it maybe next week or in 2 weeks. So this will be bundled with Raven. So in the future, when you install Raven, you'll get modifiers with it, and of course, Raven can make those modifiers for you. So you can start asking for little modifiers directly on an object without having to open Grasshopper. So that's a bit of the future for you. And then another thing that I think is like maybe the most important part of building AI design tools, also for CAD, is knowing what changed. If you have an AI work in your actual production model and it makes a change, you need to know exactly what was changed, because otherwise 2 weeks down the lane, you'll figure out, oh, actually, my agent deleted this really important thing that I needed out of my model, right? So seeing what was changed by the AI is really important. So what we've just actually rolled out last week in Raven is whenever Raven makes a change in your existing Grasshopper file, all the new components are highlighted green, and you get a little summary of like how many components were added, how many were updated, and how many were deleted, so that you can audit very quickly sort of what was Raven doing. And you can say, oh yeah, I'll accept this or not. Because otherwise, Raven just does stuff, or like any AI, will just make changes in your CAD file, and you don't know for sure what changed. So how can you trust it? And building trust and making sure that you know exactly what was done, I think is also one of the core parts of any AI design tool. So we hope that with this sort of more interconnected workflow, we can go from this very linear flow that we have today. This is also AEC coded, but it's true for all industries, to maybe more of a interconnected one, where going going into a BIM model is not something that you do at the end of a workflow, but because of Raven, you can very, very quickly evaluate a model in different stages, right? Setting up all the right materials and so on, right object kinds for Revit should not be something that you do at the very end and then you figure out that something's wrong, but instead you can connect all of the softwares together more quickly and more early on in the design process. And we think Raven is exactly the thing that will interface you with all those other things, right? Putting you in the driver's seat and making sure you know exactly what an AI changes, making sure the UI is easy, the modifiers idea. You can stay in your direct interaction designer graphical user interface that you love, just Rhino. You can push boxes around, but you get the full power of the parametric tools. So if you want to, you can go really deep. You can have really complex computational design done with Raven with as much of your own doing as you want, right? Raven doesn't need to do it all for you. It can only be there to assist you. It can only help you optimize scripts or help you when you're stuck, or you can zoom out and have Raven handle more and more lower level tasks. So that's what we believe in. Plus, the world of Rhino and Grasshopper, which is our home, we think is the future for AI-based tools. If you want to, learn more why, you can look up some of my other talks on YouTube. But basically, we call this the Rebel Alliance. We think a lot of different people that are really good at like specific things, like Kuramba, for example, being really good at structural analysis, they will just build the structural analysis part, and Raven will sort of tie all of those existing tools together, so you get more out of Rhino, right? In theory, Rhino has so much to offer. There's so many tools other people built on top of it that you can probably replace most other CAD software with it, but you need to know about them. You need to have them all be interoperable and sort of seamless. So that's what we hope Raven can do, right? It can unlock all of those Rhino capabilities for all of you guys. So that's what we believe in. That's our mission. And I see I'm right on time. So for those, actually it was in a different, I need to switch back to this one. Our schedule was that I end just now. So I see that seems to work. Okay, the chat is still fairly quiet, so I'm guessing everything's looking good. Let me just check my Zoom. Okay. Now what we'll do is set up Raven together. Part of this workshop will be that you guys get a workshop license, which means for the rest of the day, you won't hit any limits. So we can work through, the entire workshop together with your new Raven accounts. And by tomorrow, I think you'll be back on the free tier, so you'll have a free Raven account. But today, you basically get the pay level limits, I think. So I'm just going to share a link that you guys can use to sign up or upgrade your existing Raven account if you're not on a paid Raven account already anyway. So please follow this link and then sign up, create an account. I'm just going to try it, make sure it works. Okay, so if you create a Raven account through this link, it might also ask you to upgrade your existing one. That will allow you to have more usage on Raven than if you use a normal free account. So that's just for the workshop, and it's going to be very useful. So please use it, make use of it.
And Moritz, does that have an expiration date for them?
Yeah, so it will just flip them back to free by I think tomorrow. So at the end, yeah. So that's just after the workshop you can use it a little bit more if you want and go wild, and then by tomorrow it'll just be a normal free account, which still has daily limits. Every day you can use Raven. In the first few days you get a little bit more, so you can explore more, and then over time I'll show you ways to make the best of your tokens, but it's basically we gift you a bunch of free tokens every day even on the free account. So you'll be able to ask questions about scripts and things like that, even if you don't convert to a paying user, which are many of our users. We're proud to have thousands of users, even if they're on a free account. They still find a lot of value in Raven with the daily free tokens that we offer. So once you have this account, you sign up, you'll get an email, and then you follow that email to set your password. Now, I'm not going to do that on the window, like show you that, but just go through that flow, and then I'm gonna open up my Rhino now and walk you through the install process, which is also very straightforward, really very easy. So, okay, so I'm going to just open up a blank Rhino project, and then you will want to type package manager. I'm also going to paste this into the chat, but package manager, for those who are unfamiliar with it, it's basically like the app store for Rhino. So that's what we will use, and I'm going to paste it in the webinar chat as well. Package manager. So this is the command that you run in Rhino, and it brings up the package manager. Then if you run Raven, if you look for Raven, you can see newest version from this Wednesday. Perfect. If I actually recommend that you keep this automatically update packages down here ticked, because we update every week almost, I think sometimes twice a week. So you get all the new features, bug fixes, and so on. If you keep this tick on every time you open up Rhino, it will fetch the newest version of Raven. And then you say apply. Oh, wait, I forgot to install. Okay. You open it up, package manager, open up Raven, select it, and then you click install. And it'll, download Raven. It's all very fast. And then you say apply. So now you have to restart Rhino. So you quit Rhino and then just open it again. And when you restart Rhino, Raven will be installed. And the way to see whether Raven installed successfully is just to open up Grasshopper. So I'm going to type Grasshopper. And this is a faulty plugin that's not Raven, luckily. And there you can see Raven is now successfully installed. So I get the button right here on my canvas, and it says Raven. And you can also open up Raven by typing the so there's a question if you already have a free account. I think if you are logged in on your browser, so if you go to raven.build and you're logged in, and then you open up the link I sent you, you should be prompted to upgrade. But if that doesn't work, I'm sorry, you might have to create a new account with a different email. This is a response to Garden. Okay, perfect. So if you have Raven installed, there's a Raven command you can run. You can open up Raven here, or you can basically clicking this button will open up the Raven window, and it will also create a new Grasshopper file. So you see, we now are in a blank Grasshopper file because we didn't have any open. Of course, we can also close the blank Grasshopper file with file close, and then we can open up another one. Yeah, but that's fine. So we're gonna start from a blank file, and I will just run you a little bit through the UI and all the tips and tricks to get started. So I hope you guys can follow along. Please let me know in the chat if I'm too fast or if you have any issues. But by now you should have created an account, set a password, and then downloaded Raven in the package manager, restarted Rhino, and then opened up Raven. So you're at the same stage that I'm at right now. And then let's just say hi. So actually, you will not be logged in, which means you have to still log in. So I'm going to log out as well. So and now if I say hi, I'll be prompted to log in with my account that you guys just created. And then I will just log in. So the question in the tab is, where do you install Raven? You run the command package manager in Rhino. That's how you spell it. And then you open up the package manager. It's kind of like an app store. So you just look for Raven, select it, install it, and then you have to restart Rhino, and it should be there. So that's how you install Raven. And you can see I'm now logged in as well. So up here, it doesn't say log in anymore. Now, for me, it says pro. So if I say hi, I can start talking to Raven. And Raven says, hi, I can help you build and edit Grasshopper scripts in real time. Since the canvas is empty, what would you like to create? Okay. How do you talk to Raven? There are, here down by my message, there you can see there's a couple of things you can select. There's a fast and smart model. So the fast model is a lot cheaper token-wise. So if you're for today, it's fine. You can just switch to the smart model. If tomorrow you're back on the free version, if you go to the fast model, you'll have a lot more mileage, but it's not as smart. So there is also a way to add images. So if you click this, you can add an image of a raven, and you can also then draw on the image. So you can raven can get a little top hat. There we go. This is basically a way where you can upload, something you found on the web, maybe a building, maybe a shoe sole, maybe an interesting parametric structure. And you can say, hey, Raven, like this is part of my prompt, send the image, you can sketch on it, you can highlight the thing that you're most interested in. So that's how you add an image. Now I will just click into my Rhino, type box, and just add a box because I want to show you the next feature, which is this little camera icon. So if you click the camera icon, it also adds an image, but it adds an image of your currently active viewport, which means in my case, it was this perspective viewport. Now, if I click into another viewport, which is the side view here, and I zoom in on something, let's say this corner, next time I click the camera, the active viewport will be picked. So you can see it basically grabbed the screen cap of this viewport. So I can use the camera icon to compose a couple different images when I want to put Raven's attention on something. So here I have 3 different images that are all made using the camera icon, and you can just zoom in on the thing you want to show Raven and click on the camera. This is super useful because Raven usually doesn't visually check the canvas to the output, so it works just strictly on the Grasshopper canvas. So it's very useful to show Raven some context or to zoom in on certain things or give feedback on the thing that Raven came up with visually, right? So now I'm going to remove these images again. And the third item is the mode. So I already mentioned it, there's edit and ask mode. And if you switch into ask mode, you can talk to Raven, but it can't make any changes to your file. So as soon as you want to be able to change, want Raven to make changes in your file again, you can just switch back to edit. It's super useful to also just plan out changes. So if you have a big complex file, and you want to talk to Raven to make a plan on like how to fix something or how to change something or optimize part of your file, you can do it in ask mode. So it will just be a discussion with Raven. It won't be making any changes. And then when you're ready to go, you can switch into edit mode or you can make the changes yourself. So it just gives you a lot more control over when Raven goes around and makes changes. And smart and fast, I already mentioned it. Smart performs much better. But fast is a lot more token efficient. So as long as you're on the paid version that you are on today, you should be fine. 1 second. So if you opened installed Raven, you just open up Grasshopper, then this little button shows up and you click on the button and then you get Raven. So let's get started. I'm trying to come up with some. If you want to suggest something to make, put in the chat. So if you have anything that you want to see Raven build, please write in the chat. We can also make a top hat. Of course, there's like very classic examples like make a spiraling staircase, which is a very classic Grasshopper example. You can change how many steps there are and so on. So I'm going to start with an easy one because also one of the things is, of course, it takes a while for Raven to solve a problem like this, even today, even with the modern LLMs. So we can make a complex facade, but the first thing I want to show you is something that maybe, we can get it right on the first try and we can play with it a little bit. If you keep it on smart, you will get better Raven, but at higher token cost. So for the workshop license, that's fine. And then tomorrow, if you're on the free license and you want it to last longer, basically, you can put it on the fast mode. Okay, because I wanted to point out some new things in the UI as well. Basically, down here, we already ran through all of these parts. If you want to stop Raven after asking a question, if you don't want it to continue, you can click this button right here. But I don't want to do that. I actually want my spiraling staircase. If my audio is bad, I can put on headphones, but please let me know if this is for everybody or only for Nicola. So Raven is now making a plan to build this spiraling staircase, and you can look into its thought process. So here in the UI, you can see it. You can see some thoughts that you can flip open, and then it's making tool calls. So it's creating a plan, calling component searches. So it's looking for the right components to use. And now it's coming up with the Grasshopper script, the entire Grasshopper script, which it takes a second, and then you will see it appear in my Grasshopper file. There we go. So this is the first iteration. You can already see there's an issue. And one of the components is orange. It's not working correctly. So Raven will see this issue, and it will fix it in the next edit script. I'm sorry, I'm really hot. Okay, so the component was fixed, but it's still not correct. Everything's green because Raven just made all of these components. So as we, as it makes fixes here and changes things, in the future, the components that Raven just added will all be green, and the others will not be highlighted. And you can already see the parameters that Raven picked. There's the outer radius, the inner radius of the staircase, the thickness of the steps. I could have, of course, said, I want the spiraling staircase that connects to the central pole, or I want it to be floating or anything like this. But I really didn't specify anything. I just said, make a spiraling staircase. So now Raven had to basically decide which kind of spiraling staircase, what kind of shape of steps, and so on. And now you can see it's even making groupings. So I didn't ask it to make groups. Of course, I can say, don't make groups, or I can ask it to make groups. But there's just like basically a standard thing that Raven does. It likes to make groups. So if you don't say anything, it probably will start making groups. And if you ask it to not make groups, you can, it won't, right? So it's up to you what you ask Raven to do. And now it's done. And so here you can see 22 components have been added. Do we want to accept this or not? Of course, to me, the spiraling staircase looks pretty good, so I'm going to accept. And now, if we zoom into our canvas here, you can see Raven has created an input group with a couple parameters. It made a separate group just for the column, which may be unnecessary. And then here, these components construct the base step. So if we select them and then, oops, sorry, preview only the selected components, you can see these components are making the base triangular step shape. It's not quite triangular, it's a rectangle actually. And then it's moving them. Here, the spiral array, you can see they all get moved upwards and then they all get rotated to a different degree using the series component right here. So I will turn off the preview for the non-rotated steps, and we have a spiraling staircase, which is of course parametric. So we can go in and say it actually rotates further or less far, or the inner radius should be larger, or we can even say we'll hide the central column, so it becomes more of a floating situation. And now we have this basic. I don't get any more complaints about my audio, so I'm assuming it's good. We have this basic thing to start with, and we can start changing other things. So one thing I want to point out to you is Raven can never make a change that you cannot undo, right? This comes back to the control aspect and to knowing exactly what was changed. So if we now look at our chat interface, you can see I asked to make a spiraling staircase, and then it says here 11 tools were called, and it's kind of hidden. So if you click on it, it unfolds the entire process again that we saw earlier. And you can see there are little undo buttons in a couple of places. So whenever Raven makes a change, like when it calls a function to change something on your canvas, to create groups or something, you can always undo that change, because basically what we do is on your computer, we save a local state of the Grasshopper file. So if Raven makes a change that you don't like, you can always undo it, okay? Always. You can do that using the accept and reject interface that we saw earlier with like the green highlighted components, or you can select specific things that you want to undo. So for example, I might not like the groups that Raven created or the relayout. So I can just pick the thing that I don't like, and it will basically revert the conversation and the canvas state up to that state, that moment in time, right? So I can like go back to a different moment in time. So I will just say undo the relayout graph. So we have this group components, but before the relayout. And I will also undo the grouping of the components. So now I have a vanilla Grasshopper file. Before, it's the same file, same logic, but it's the state it was at before Raven called those other tools. So I can now continue on from here, right? So instead of basically having to accept all of them in one block, I can also undo specific things. And right here, this undo button, it will stay there. So as I continue with this conversation, I can just go and undo a whole block of things up to a different state. All right. So by the way, if you don't, if this Raven button, you can hide it if you right click and say hide Raven UI. So you can also always just type Raven and that way, like open the chat window that way. It's not just using the button, just because somebody thought the button wasn't intuitive. So you can, if you just look for the Raven component, that will also open up the chat window. All right, now I can again, ask Raven to group and reorganize my script, but I don't actually want to do that. I want to build on top of it. So let's say add a handrail and a side wall, maybe something interesting. I'm trying to get to a point where I can maybe sketch also over part of it. Yes, so the outcome is different every time you ask. Even if you ask the same question, it will be a little bit different because of how LLMs work. And the more specific you are with your task, the more similar the outcome will be. So if you have a very like well-defined prompt for how you want your script to be, Raven can make it multiple times, right? But if you have the more open your prompt is, like make a spiral staircase, it has to make a lot of decisions. So the more decisions it has to make, the more new the result will be every time. Because for example, it decided to make this exact kind of spiral staircase. It could also have chosen to make a spiral staircase that's kind of swooping and doesn't have a central pole, right? So if I can ask for a specific thing, or it will just come up with something. So here we have a side wall and a handrail, and you can see that the newly added components are highlighted green. So it's fairly easy to see, where the handrail is added, and so on. And now maybe it'd be interesting to do. Oh, it's also doing grouping again. That's fine. We can keep it. I wanted to show you how we can maybe sketch over a screenshot, which could be interesting. So grouping and layouting things nicely in Grasshopper is actually a very hard problem to automate, but we try. We do our best, and so Raven really likes to group stuff. I will accept these changes, and then what I want to do is zoom in on a specific part of my spiral staircase, and then say screenshot. I'll click on the screenshot, and I will say cut out holes like this. So maybe like a decorative element. Can you cut out holes like this along the entire side wall? And I'm getting a new question. You can absolutely use your native language. So sometimes it's easier to express things in English because the component names are English. So like extrude, for example, I wouldn't even know how to say that. Extrudieren, I guess, in German. So it just comes more naturally. But for Raven, it makes no difference. So it's actually very popular to use Raven in different, completely different languages. So the Rhino exists in different languages, right? There's a German translation for Rhino, but there's not for Grasshopper. So a lot of people were just locked out of Grasshopper from a language barrier. And I think that's also a big place where Raven helps people is you might know what you're trying to achieve, but you don't know what it's called in Grasshopper. So like, you know that you want to make a box shape, but you might not know that it's not called like rectangle but box or something. You know, like you need to know the exact wording of Grasshopper. And with Raven you don't, because it can just help you find the right components. And a lot of people use it in, you know, anything. I mean, Spanish is very popular. German, of course, also, because we have a big community there. People use it in Japanese, in Korean, in Arabic, in any language really. Yeah, that's what we see. You can just ask Raven to make a change. Like if you didn't solidify the steps, you can just say solidify the steps, or you can just do it. It makes no difference actually. Raven is supposed to work together with you. So if you want to do it yourself, you can do it yourself. But if you want Raven to do it, you can just tell Raven to do it. So that's fine. It doesn't matter if you do it or if Raven does it, because we really built it to do work together with you, and not to only give you one result and you have to change it yourself, or to do everything. So now I'm going to turn off some of the previews here again. Wall withholds, yeah. Preview off. Yes. So we should be able to see. It's not quite right, huh? Okay, so Raven made the holes. Oh, actually, I can probably just change the diameter of the hole, and then it'll fix it. Okay, yeah, now it works. Now if I turn off this preview, now we have our wall with holes in it, and somewhere else we still have a preview that the wall with holes here. So I just changed some of the previews, so now we have our holes in the wall based on the sketch. So okay, this was just the basic one to get started. There are a bunch of other things in the interface that I want to show you as well. So now we've seen sort of the basics, how you author, you know, give Raven a prompt, add an image, add screenshots, sketch over the images and screenshots, edit and ask mode, smart and fast mode. Now I want to go into the settings. So up here next to the title, so Raven gives your conversation a title. You can click this top left button and it will open up your past chats. So you can see I talk to Raven a lot. And you can create a new chat. So if you click this button right here, you can create a new chat. You can keep talking about the same model in a new chat if you want. Then here you can see the name of your Grasshopper script. So what happens is you can have Raven keep working in the background, and you can open up another Grasshopper script, and it will ask you, do you want to switch or not? You know, you can open up any Grasshopper script, and Raven will keep working in the background, right? And if you want Raven to come to the new script with you, you can click this this tick, or you can just leave Raven working in the background on another script. Also, here you can always see which Grasshopper script Raven is currently connected to, because actually in Grasshopper you can have like 5 different scripts open sometimes, because you know you grab something from this script, paste it in that one, and so on. So we added this little thing right here that always tells you which script. So if I save the script, call it spiral, then you will see. Actually, I have to ask a new question, and then Raven will update, and it will say, "Oh, I'm in the spiral file." But up here, there's also a couple other things. So this is the account button. So here you can see your account, but also right next to it is the settings button. So if you click that, the settings unroll and open. And here's a bunch of things I want to show you. First of all, there's the profiles. The profiles are basically a way to make Raven custom and a little bit more advanced to specific workflows. So if you open up the profile dropdown, you can see there are some official ones that we've built, which are basically normal Raven with added instructions and information on top for specific things, like how do you teach somebody Grasshopper? So if you turn on Raven Learn, now Raven will not make changes for you, but it will guide you to understand parametric logic better and help you to learn Grasshopper. But there's obviously, most of these are for plugins. So for example, Kangaroo 2, this is something I want to show you guys later, is a physics simulation plugin that ships with Grasshopper, so everybody has it, which is why it's great for demos. There's also, of course, Ladybug, which is very famous for sunlight and energy analysis and stuff like this in AEC. There's Rhinos at Revit, ArchiCAD Bridge. Basically, if you turn this on, Raven can already use all the plugins without turning it on, but if you turn it on, it just knows more about the plugin and makes less mistakes, so you get to your result faster. Tekla LiveLink, for example, as well, it connects to a structural analysis software, and this, or Tekla or Revit, they have a lot of structures that are unique to that software. It's like a lot of specific context, and you don't want Raven to know this whenever you use it. You only want it to be like kind of given extra information if you're working on this thing. So I'm just going to stick to standard for now. And then there's custom instructions. So for example, never group without me asking you to. I don't want Raven to keep grouping things at random interval, like moments in time. So I can just say never group stuff before I ask you to do that. And always speak German, for example, right? So I can, any preference that I have, any personal preference, I can put it in here. Every time I use Raven, it will remember this. The live sync for ArchiCAD is not developed by us. It's actually developed by ArchiCAD. So you can just figure out how to install that on their website and everything. But once you have it installed, you can then use Raven with it and turn on the ArchiCAD profile, which we made. So the installing and the plugin and everything of that is on their side. And then making it work with the Raven is on our side. So the other button right here, Python and C#, it allows you to disable Raven from writing Python and C# nodes. It's very cool to write Python and C# nodes, but sometimes it can get in the way. So some of our users want everything to be normal Grasshopper components, so it's easier for them to understand what is happening in the script. Others want advanced capabilities, more complex math, or you want to call, an external API or something like that. So you want Raven to write Python C# nodes. The standard is that it's turned on. So not in this example, but some of you might be prompting other things where Raven decides it's time to use a Python node, and it will just weave the Python node into the larger Grasshopper script. We also have a help page. So if you click this button, it'll open up the help page. And then here you can see all of the plugins that I have installed that Raven automatically finds and registers. So Ladybug, Parakeet, these are all plugins that I've installed, and Raven finds them and sees like, oh, you have this plugin installed. If you don't want Raven to ever use that plugin or be aware of the fact that you have it, which is basically, sometimes it will start using Ladybug components when I don't want it to use Ladybug components. So I can just click here and it will turn off those plugins. So Raven will not know that you have them installed, and it will not be able to use them. Otherwise, you don't need to turn this off. It only uses those plugins if it uses component search and it finds like a good way to use one of the components. So it's not a problem to just have them all turned on. But if you explicitly wanted to stop from using one of the plugins, you can turn them off. So there's a question on Revit, Rhino inside Revit. If you have a Rhino inside Revit setup, which basically means you have Revit and then you download and install Rhino for Revit, and then you open it. If you have Raven installed in your Rhino, it will open also in there. So you can just click the Raven button, it will open up, and you can start using all of the normal Rhino functionality. Plus, because you're opening Rhino inside Revit, it will have the extra tabs for all the native Revit components and families and so on. And so it'll be the same Raven experience that you have everywhere, but it also works with the Rhino inside. And there's no specific setup that you have to do except the normal Rhino inside Revit setup. I hope that helps. Okay, so I think I'm going to take a quick break and get some water, and then I'll be back in 5 minutes and show you guys some the next workflow. Okay, so yeah, you might also want to get some water or not. For me, it's like 34 degrees Celsius, so it's very hot. I'll get some water and then I'll show you guys something else. You can also maybe think about what else you'd like to see next. Yeah, and then I'll see you in a bit. 5 minutes. The pro or not pro is connected to your account, so it doesn't matter what you have. Like everybody installs the same thing. It's just how much usage you get. So you can always sign out and sign back in. I'm just responding to stuff that's happening in the chat. If you, I think people were successfully upgrading their account to Pro for just today. So if you're logged in raven.build, you go to raven.build, our website, log in, and then you click the link. It should prompt you to upgrade if you're in a logged in browser. If you upgrade, it should automatically, might take a few minutes, update you in your chat as well. For now, as long as you're not hitting the usage limit, don't worry about it. And you can always sign out and in, back in inside of Grasshopper as well. Perfect. It worked for Rodrigo. Very good. All right. So that was 5 minutes. I'm gonna start sharing my screen again, and we can explore some more together. Okay, I'm happy to take any suggestions, so things that you are interested in seeing from any industry, any domain. So please, if you want to, before we dive into the more thorough workflows, any more demos that you would like to request. Otherwise, I think it's often you have things in Rhino already that you want to sort of embed your demo into. So I'm going to I will quickly open up a Rhino file. Okay, some proposals are coming in, which is great. So let's check it out. So first of all, okay, if you guys want me to use an AI generated image, if you want to, you can create the image and then send me a link to it or something. So I don't have to, bore everybody with me prompting an image. So if you want to go create an image and then send me a link, I can use it. Otherwise, I'll try the topological surfaces, the Schwartz P surface. So out of my domain, not familiar with it, but I'll just ask Raven, can you help me model a parametric Schwartz P surface? Let's see what we get. I expect this is the kind of problem where Raven will draw from Python and C# snippets. So let's see. Otherwise, there are some other suggestions. So it's actually looking at different plugins I have installed. So it decided not to use C# or Python. We can, of course, enforce that, but I have some pattern generation plugins installed, so it's trying to use those. I can see it says parakeet here. I don't know if that's a good approach. I feel like C# and Python would make this a lot easier. I was thinking in German because I told it to speak German. Of building rules info to use as a template. I will also show you Raven integrating with pre-existing scripts. Let's do that next. It's an easy demo. Speaking German, sorry. I'll take that out again. please just use Python. Sorry, I can't find you. Click your link to look at the image. Aryan. If you guys want me to do things like use building rules to make a feasibility study, if you can send me the building rules, I'll do it live. But otherwise, I just have to make a feasibility study, from a void kind of, because I don't have building rules to draw from right now. And I also want to do the voxelized tower with you later. So I have that. I have a Google Drive with 2 images that I'll share, and you guys can follow along also when we're doing that. Right now, it's writing Python. Ooh, nice. Okay, Raven wrote a Python snippet here. Oh, it's like voxelized for some reason. But it does look like the surface you're looking for. Um, yeah, it looks interesting. Okay. Schwarz-P-Fläche, frequency. Here we can change the resolution. Okay, I'm going to accept it. And I will go into the resolution, reduce it a lot. Actually, I need to bump it up. I suppose that the Schwarz-P surface looks like something that Raven can calculate through voxels. So, here we go. So it's doing a voxelized version using Python for a minimal surface. It's still writing in German. I'm sorry. I will fix it in a second. So yeah, I guess it's a good start. It's making a molten mesh of it. You can probably ask it to do a NURBS one instead, but this is your demo for the Schwarz-P surface. I'm gonna create a new file, move Raven to a new file, because I have a screenshot of the image that Aryan shared. So can you make a donut like this with the minimal surface infill? Use Python for the info. I just don't want Raven to try to use native components again because I just think it's faster to do it in Python and I don't care about it being made in native components. So I just explicitly said, for the infill, just use Python. So Rodrigo, if you want to see a feasibility study, do you have some building info prompts that you like project brief maybe that you want to use, and then I could show you if you want. Otherwise, after this, I promise I'm going to show you using Raven in an existing script. Perfect. You can see, even though I told Raven to use Python, it still went in to look into Dendro. I can show you guys the plugin. It's cool. It makes sense. You can probably do some of the work with Dendro. So whenever Raven starts to think for a long time, that's when you know that it's writing a big script, right? So first it did a lot of tool calls to check out a bunch of things. And then now it's taking a while, so you know it's actually writing the edit that's getting ready to make the script. And there's errors, but that's okay. I think Raven will figure them out. And there are some Dendro components it's using as well to mesh, take the points, create volumes from them, and mesh the result. And the color component as well. I'm sorry, this might be a bit boring waiting for Raven to fix the Python file. You can upload PDFs to Raven. So if you want Raven to look at a PDF to like figure out how to, maybe a research paper on minimal surfaces, you can definitely upload it, and Raven can use it when you ask it to solve something. That's also just with the same way that you upload images. I mean, I just like to have native components. I think it's a much better approach for a lot of the stuff I discussed earlier. Knowing, seeing through the black box, seeing everything that's going on, knowing you can trust the components. But I also know that the minimal surface stuff, I have Dendro, so you might be able to do it with the normal components, but doesn't always make sense. Sometimes it makes sense to do things with Python. So it's just a feeling thing, I think. So Raven's still trying to debug this Python file. I don't really want to keep you waiting any longer, so I'm just going to stop it, actually. And then you can see I can still accept or reject the current state of the script. But I wanted to open a different one. So I will just quickly stop the share and open the voxelized tower so I can show you Raven in an existing file. Mm. So I'm loading the voxel tower right now. This takes a second because it's a big file. Mhm. Mm. Okay, I'm gonna respond to some of the questions. Basically, using Raven for G code, I think it's definitely possible, probably can help you a lot. But I don't do any G code generation, so you'll have to try it yourself. And there's some really good plugins to do G code generation. Plus, you can use native components, and you can use some of the coding components. So I think you'll have a lot of luck uh, using Raven for G code generation. But I don't have anything I can show you right now. Also, possible to share other sources? Yes, it's possible. I think I replied to your question. What are the next things on the roadmap? We are actually working on a Rhino integration. So if you want help in your Rhino workflow and not just in Grasshopper, send me an email because we are working also with a very early beta program to make sure our Rhino integration will be useful to all of the real work that you guys do. So also I have my tower up now. I'm going to share my screen again. So this is a fairly big file. Also, I had to open a bunch of files, so I'll close them again. Okay, this is the voxel tower from the video earlier. And now you can see, I mean, it's not that big, but has a couple more components, and it also, it's kind of slow. So when you make a change, it calculates everything, every balcony again. So I'm just going to open up Raven in this existing file. And just keeping an eye on the chat as well. Just ask Raven, what does this file do? Are there any inefficiencies? Actually, it's in fast mode, so I'm going to switch it to smart mode for the next question. But I just want to show you how Raven can understand really big files as well. So in the video, I had a ladybug file, but now this is just normal geometry. And you can see Raven's checking nodes, which means zooming in on specific parts of the script. It's understanding, okay, it's a voxelized tower, zooming in on new parts. Because I asked about the inefficiencies, he's probably going to start analyzing. And here it comes back and tells me about the script. So this generates a voxelized tower. Key inefficiencies that it found is there's a broken geometry error, there's a performance bottleneck, because region union. Can you zoom into the region union node? So it's telling me about the inefficiency, but I'm not sure where that is. So I'm asking it to zoom. Sorry. Okay. So it misunderstood. Instead of zooming the canvas for me, Raven zoomed in on a node. So I'm going to go back to my question that was misunderstood, and I'm going to change it. So there's a small little edit pencil that shows up if you hover here. Can you zoom my canvas into the region node? And then I will rerun with the updated prompt. So there's just very small little UI elements like this that allow you, to go back and change the thing that you said so that maybe Raven gets it, understands it better this time. Is the region union already here? Huh. Ah, here we go. Now, okay, you can see it selected the group and it zoomed into this group. And here there is the region union right here. And so apparently this is a key performance bottleneck because it merges thousands of grid cells into floor outlines. Large number of grid cells to make the script run significantly faster and fix the current errors. It's making some suggestions. But I don't actually want to like go and get lost in the debug now with Raven. But you can see using an existing script, it can find its way around. It can zoom into different nodes. Maybe now zoom my canvas to the facade subdivision logic. And it's super easy to ask questions and to understand and maybe also find performance bottlenecks in scripts. So here, this is where the facade elements are. I wonder what this one does. What does this component do? And now Raven knows what I have selected, so it can give me a direct response about the thing I just clicked on. So he's giving me an explanation of the entire group, but now I'm asking about this component specifically. And it's telling me, oh, this is a deconstruct prep. Here's what it does. Here are the inputs and outputs. How are you getting the component name and numbers? So Raven can sometimes write something called a tag, so a little note to each component, like a comment, what that component does, right? It's a tag. So here it's saying this join is the join outer balcony edges join. But on a really big script like this, you see many of them don't have tags written by Raven. It's basically like a comment, like in coding. So I can also request a comment. I can say, write a tag for this component to explain it. Also, all of the components have numbers because that's how Raven refers to them. Okay, those numbers they only show up if Raven writes a tag for the component. Then you can see 902 move to roof. Now, I can't see the tag change. Okay, but Raven will just sometimes write these comments for himself. If you don't want to see them, you can also turn them off. I think if you turn on full names, they disappear. And if you have sunglasses installed, then there's like a conflict. But they're basically just comments for Raven to understand what the components are doing. Okay, now I actually want to go and rebuild this tower with you guys as the next thing that we do in this webinar. So we go from, like little demos into a more longer workflow. So this is going to take, maybe half an hour, but I think it'll be fun. There will be a lot of going back and forth. And if you want to follow along, I'm going to share a Google Drive folder with you that has the basic sketch in it. And then we can, do like a thorough workflow with Raven. So I'm going to share the link. There's two images actually in the chat. Copy the link. So if you just go here, you can download the first thing. It's called screenshot. If you just download it, we will use it in a second. And I'm just going to make a completely new file, and we'll build this a voxelized tower. We can, make it different than the one I've already built together. Okay. So I also just downloaded it, so we actually have the same file. And I'm going to start sharing my screen again. Okay, so I'll have the chat right here. So make sure you're in edit and smart mode, and then we'll get started. This is the image that all of you guys have. It's a sketch that Philip made, and it's a good starting point. And now you don't have to do the same prompt as me or the same sketch. You can sketch your own thing. But I just want you to see also what a workflow over longer time, like over a longer period, looks like with Raven. So not just, one small little prompt, one small little staircase, but something more thorough like this voxelized tower. So let's build this voxelized tower. Already, I want to maybe specify a couple things. So the base shape is elliptic and rotates. The voxels are the same constant size across the floors, but the ellipse tapers. So we have an ellipse, so like a circle, but a little squeezed. It rotates and tapers. So I forgot to do the rotate part. Rotates and tapers. Let's just get started. So I'm telling Raven, but we're just doing the first step here. And Raven is taking the sketch and my prompt and is getting started. If you want to use the same prompt, I'm going to put it in the chat, but you can of course write it, including my typos. The previous chats are accessible here in the top left corner. If you click this, you can see the past chats. The only thing that's not still available is the undoing, because undoing is only a temporary file. So when you close Raven, all of the undo states are gone. So you can open up the previous chat and you can continue it, but you cannot recover the undos. Mohammed. Raven is taking a while here. Maybe there's an issue, or maybe it's just thinking thoroughly about my request. I'm not sure. Okay, so now it's starting. It built a plan already. So I'm happy. I think it's going well. Ooh, pretty big script Raven came up with here. So in the video that we have of this process, it's actually more little steps. And this time, I asked for the whole thing in the from the first start. So that's why it's also taking longer. Now Raven will fix some of the issues, and then let's see what it comes up with. I already see that the lips are very, very narrow. And zoom in, you can already see the parameters Raven shows. So how many floors, what's the rotation angle in radians, what's the maximum extent of the ellipse, maximum, minimum, same for both directions, Y and X. There's a grid size, which is like my voxel size. So all of these things Raven's coming up with already, and then the height, which I guess is per floor. Couple issues remain. Oh, something's happening. It looks a little bit like a video game sculpture. and the errors are gone. Great. So I think what we need to do is increase the size of the ellipses. So even while Raven is working, I'm going to start working as well. And I will go in here and I will say the minimum for both X and Y should be a lot more. The minimum Y, let's do 12. So looks a lot more like a tower. Of course, maybe we also need to increase the max so we get the elliptical shape back. Maybe this is overall a bit too much. So now we're both working on the graph. So Raven is calling relayouts. Now it's done. See, it's happy. I can say, yeah, this looks great. Great start, right? I mean, my ellipse reshaping maybe messed some things up here, but so basically at the top and at the bottom we have an ellipse, and we can shape it. So because yeah. Nice. Okay, there's a good rotation. So actually, what I like about the other design that we had, and I'm also just gonna add more floors, is that this is a nice voxelization. You know, it works. Like this is like what it looks like when you do a voxelized twisting tower like that. But I would actually prefer if maybe like if at every floor the voxels are also rotating, right? That's how we get these little balconies. And that's how we get these little gaps in between. And I think it makes the whole thing more interesting. So 20, I'm still playing a little bit with the ellipses. Minimal X, let's say you are 12. To accentuate the shape a little bit more, okay. And it's exactly one rotation, so we can also change that a little bit. We can say a bit more. I'm going to ask Raven to rotate the voxels at every level. So the voxels should also rotate per floor level. So I don't know if you guys are following along or not, but basically I want to go through this longer workflow with you, where we can also, you know, add a facade, panelization, and so on. So you can see how you can go beyond simple examples, and you know, sometimes you call an undo, you go out back and you change your prompt and you run it again, and things like this are totally normal. It's a normal part of working with Raven because it's an AI and you both are collaborating on this, you know, and you can really like fiddle with the sliders, figure out the elliptic shape to be just right. I actually want it to be a little bit wider at the top here, so I'm just going to say 15. And that's a great thing also about Grasshopper. It gives you the UI, you know, to work with. But there we see Raven already made a change. Now we just have to fix the previewing, but it looks pretty good actually. I'm going to turn off these previews. Look at that. Nice. Very cool. It's almost too much. So now it comes, you know, to questions of design. So I will accept this change, but I will actually now say, give me a slider with int numbers. So full no, integers. And the number selected, such as 3, are the number of floors that are grouped to rotate together. So instead of each floor rotating, I can select, my typing is not very good, the group sizes with a slider, and they rotate per group to still align with the total rotation. So this is like a design choice, right? So what I'm looking for, like now, we have so many floors that I think it looks too smooth because I like the fact that it's voxelized. And so what I'm going to do is I'm going to sandwich them and say, okay, these three floors rotate together. So they rotate further, right? They rotate all the way to the, I actually didn't specify that, but I hope that the way Raven interprets it is that those 3 or 4 or 5 floors will rotate to the rotation degree of the last floor, and then to the next and the next, and it will create more gaps, bigger gaps, and more visual sort of clunkiness, which for a voxelized tower, that's what I want. But so far, I think it's going pretty well. I mean, Raven's doing well. It's giving me my voxelized tower. And we can also, if we want to increase the clunkiness, of course, change the voxel size. So if we look in here, there's something called perfect grid size. Go from 3 to 5, and it should be more clunky. There we go. Ah, interesting. So now the height of each floor is no longer aligned. So they become sort of sandwichy. So I'm going to change that again. I liked it better when it was cleaner, the grid size and the height aligned. Okay, but Raven actually already fulfilled my request. And I can now, if you look at it, you can see these groups, right? So all 3 floors are rotating together. And I will increase the group size also. It's nicely highlighted in green because it's newly added. So I will say, actually, maybe group size of 6. Yeah, that's almost too much. So now we're not tapering enough for this to make sense. Maybe we should just taper more. So the top should be smaller, or the bottom should be bigger. Max X, max Y. Okay, let's say turn this down to 10. Of course, this is designing. You just figure out smaller things. Yeah, and I'm going to turn on the group size again to maybe 4. Yeah, I think it's kind of interesting shape. So let's move on. Somebody suggested we make holes in the tower to remove some voxels. Okay, let's do that. Can you give me a slider that is the total number of voxels removed? Right. It's always nice if I already know what I want to control, to just say like, oh, I want a slider, and like say 5 or 10 or 100, like just let me select how many boxes are removed, and that removes a random selection of voxels, but they must be on the outer surface of the tower. I'm not sure how Raven is going to solve that, but I'm curious to see. Let's see if we can have a nicer preview of our voxelized tower. And of course, there's still so much left to do. If you guys want to start brainstorming about the facades that we could do, I already did the balconies last time, so maybe this time we can do loggias instead and remove the voxels. So we'll have little holes. Any ideas you have? Maybe think about a structural system as well. And I keep changing keep having new ideas about the ellipse shape. Ooh, that's somehow. Okay, see, this looks like there's some. Oh, not yet. It's just the rotating in groups creates these like interesting cuts. So Raven's thinking hard about this problem of removing only voxels that are on the outside of the tower, but randomly from all floors. Cool. There you go. See those voxels? Those holes in the tower? Very nice. How did he do it? So if you're interested to see how I did it, it gets a call pattern. So it's taking the list and the pattern is you can also ask it, of course, to explain its reasoning. It's using a jitter. So I guess just taking the lists, it's mixing it up and then splitting it at a certain length so that some of the number of voxels that I define is removed. Woohoo. Yeah, that's a lot of very noisy. So maybe I'm gonna turn the group size to 1 so we don't have this edge. You like it? Good. Glad you like it. We can select how many voxels to remove, so maybe a bit less or even more. Okay, let's proceed. So if anyone has an idea of what you would like to see for the facade, more would be better, even more than this. Some ideas for the facade. So what I will do is I will zoom in on one guy like this and then take a snapshot. I don't know if any of you are still following along, but you can now you want all the floor plates to be in a certain domain, but I don't want that because I want the taper, right? I want the floor plates to keep getting smaller, not be in the same domain. What about the facade? So last time what I did is I said it's all a glass tower, and so each window has like some subdivisions in it. This time we can say something else. Uh-huh. I like this idea for the course. So instead of doing the windows now, I will say identify 4 points in the tower that go continuously to the top, which could be used for the course. I'm loving this co-design that we're having here. Me, Raven, and you guys. Walter, is twisted box an idea for facade? Or do you want every box to be twisted? So what's happening now, see, Raven is creating all these points at the bottom on the floor plate. I guess it will be projecting them up. It's of course also just picking ones that are in the grid. And now it's making edits. So you see, here we have one that works, but otherwise might be too fine. So I think our tower is getting too narrow as a top. But I think that's a problem because it looks like one core was found successfully. So Raven says it's highlighting the cores for us in bright orange where we can't see them. So I'm going to switch to ghosted. I guess it doesn't work with Grasshopper previews. Okay. Let me just for a second try to figure out how we can see those cores. Maybe we can turn off the alpha on this. I think there's just no successful core. Ah, there is one. Let's see. Yeah, okay. We've only found one, which means we have to adopt change our script, right? So maybe less rotation, which would be here, rotation. Change that. Now there's one core peeking out right there. And then probably increase the minimum X and Y. I can still only see one core. Okay, I'll just ask Raven. Why can I only see one core? Perfect. Okay, staggered elevator cores. Let's do that. Actually, I'm going to stop Raven. So in the middle of Raven running, I will stop it. Just to show you guys. Go back and change my prompt to be. How many cores for each level? Yes. Design 4 cores that go up continuously to different levels. So 1 to the top, 1 to 75%, you could say, for the 4 cores. Also, I think at some point we're going to need to clean up our script because it's getting a lot of nodes, a lot of spaghetti. So Raven can make us some groups, name them, nicely separated, and then we can move them. I can still only see one. I just tell Raven. What might be happening is that instead of trying a bunch of points, Raven might be picking 4 points that then don't work. So I'm asking it if it is actually trying enough points because I think now it doesn't need to be any more standard than this to successfully put in the course. Actually, it's funny that you ask about rendering because I think it's not released yet, but next week you can just ask Raven to render, give you an AI render, and it will capture your screenshot like the same as you do with the camera, and do it like a nano banana render of it. It's just a little side thing. So there's 100 different ways to do that, and we don't intend to be the best rendering tool, but as a little convenience thing, we'll add it. Okay, Raven said there was a data mismatch. Grid points, blah, blah, blah. Okay, so apparently there should be 4 pipes, but there's still only one. Still only one pipe. Can we generate context model using Raven around the Voxel tower registry? Yes, are you talking about context profile? Because the context profile it would be usually more for like not just information about like one file, but more like a certain workflow. So if you do voxelized towers all the time and you know that you need to have a core and so on, you can write this up and put it into a context profile. Context, okay. Yes, actually we can do that. I will show you. Perfect. Walter wrote us a beautiful prompt that we're going to use in a second for our facade before we move on to load in the context. So to load in context, we need to have a site. So I can pick a site. You guys can pick a site. The first person to write a site, like a location, like an address, into the chat, I will use that one. Okay. Maybe we give up on the course for now. So with a little bit more back and forth, I think we could get it to work. But I say we just move on to the facade. So I will take the text that Walter sent. I'm gonna go undo some of the recent changes that didn't really help much. So I'm clicking undo. So we're going back to an earlier state of the script. You can see now also the chat box was filled with my last prompt that I made then. But I'm not going to use that one. Instead, I will copy for each outer facade surface of the voxels. MetLife Stadium Drive. Nice. Okay. So Walter is taking the lead here, giving me a location. Basically, what we do is we let Raven write Python scripts so it can directly fetch context from the OpenStreetMap API. It's not very fancy. You can build it out to be much more fancy. You can also use existing plugins for this. In Switzerland, for example, we have different like government APIs where you can also load stuff. Also, in the US, you have some public APIs to load stuff, but OpenStreetMaps work globally, and it's fine. It has like box models, so we use it for that. That's what I'm going to show you guys. It's the World Cup final match. Cool. It's a fairly complex facade that you prompted here, where each panel becomes an inflated pufferfish-like scale wrapped around a gently twisting high-rise form. Almost sounds like Chad wrote it. Add controllable bulging subtle spikes and tractor-based variation. Ooh, okay. So for a live demo, I'd like to take simpler things because then they don't, Raven doesn't have to think so long. But let's see if it can one-shot your scale-like facade. That'd be nice. Also, it's probably going to then have to calculate for a while because it'll calculate it uniquely for each surface, whereas if they're all the same, then it can just do it once and place it all along the voxels. Yeah, of course, you can delete anything that you don't want. No problem. When Raven makes an edit and you can see things have errors popping up, it immediately starts to fix them. So if you then delete it and Raven comes back with a fix, it gets confused because you do it like halfway through. Okay, so Ooh, I feel like I'm gonna quickly reduce the height or the number of floors because this might Raven might be about to calculate a lot of things. So, okay, shorter tower, cores outside the tower. Just in case the facade script that Raven comes up with is very computation heavy, now we have a lot less facade to calculate. So I can prototype here and then go back to the 60 floor version when it works. And show me the surface morph here. We're trying to work it out. Let's see what it's doing. Ah, the tractor. Yeah, okay. Script's growing very long with this added complexity of the facade. Oh, oh, okay. Raven called an undo himself, but he hadn't done anything yet, and so he undid a previous thing that he had done. So it's not good. We'll have to try it again. So we're back to our tower, and I think I'm going to make it a little bit simpler. Um, yeah, I'll just take the first part of your facade prompt for now, because it's always better to go step by step. Otherwise, Raven has to like make this massive plan and think through 100 things without ever sending it to Grasshopper. So it has hallucinations, don't get cleaned, right? And we don't get into this iterative loop when Raven can actually do stuff. Instead, it spends a lot of time just thinking about how to solve this problem without actually trying to solve it. And so it might make mistakes. And then now it just got kind of lost. But sorry about that. You can undo it because whenever Raven does something, this undo button shows up right here. But also when you go up to change the previous prompt, you can't do it while Raven is running, but when Raven's not running, you can change this prompt, and then you're asked if you want to also revert the changes that happened after this prompt or not. So that's how you can undo them. But for every tool call that Raven does that changes something here, there's a small little undo button to just go back to like this stage in time, this point in time. Do I even have pufferfish installed actually? Yes, I do. Okay. Just making sure. Also, I wanted to reduce the floors again. Because of course in Grasshopper you can always do something that suddenly needs a lot of calculation. And we don't want to be frozen. All right. Okay, executed. Let's see. Oh, one big Python file and a lot of other stuff too. Let's just see, let it fix that. So if I actually wanted something like a blow up, simulated facade, I would probably isolate the problem and just solve that in a Grasshopper script with Raven and then come back, because now we have all this other logic and we're trying to do, look, here's the crazy pufferfish inflated box. And we're trying to do everything at once. So Raven has to work within the huge larger script instead of having sort of more of an isolated problem. Okay. Actually, now I will just ask Raven to please clean up the script by making neat groups that are all in a DAG flow. So DAG is just like a directed flow graph, which is basically the standard Grasshopper. So one group feeding into the next group and the next group and having some parallel groups, but never a back connection. That would be nice. Because at this point, it's a mess. But we did get this bulging out pufferfish facade here. Actually add them to the groups and read layout along the groups. So let's check. There's also just like so much previewing right now, so I need to turn off some of this. What is this material? I mean, it's like super glossy. I wonder why. Why is the preview so glossy? Let's let Raven do some of the cleanup work here. There you go. See, it's much nicer now. Much nicer. So I know, okay, this is just the continuous structural core that's all here. Extract exposed faces. Pufferfish attractor craziness happening right here. So now if I want to investigate that, because somehow not all of our towers actually getting the pufferfish stuff. So not sure why. And all of my main controls are still here at the start. So I can go and increase this tower to 50 again. Now a lot of puffer fishing is happening. Okay, but I think it's it might be only applying the pufferfish. Okay. The pufferfish facade should happen on all the outer voxel surfaces, but now there is some. Wait, we're also deleting a lot of voxels. Grid generation, voxel extrusion, exposed faces, remove voxels. I'm going to remove 0 and then see maybe that. But now interior voxels are missing and the pufferfish is only applied to some. So you see how I use the screenshot to help Raven identify the problem, right? Because something is not quite right and I'm not sure what it is. Maybe Raven knows, maybe not. And then maybe we can also play with the pufferfish a little bit more, different attractors. Uh-huh. Now we have it everywhere. Okay. And the inner voxels are back as well. It's still very, very glossy, which I don't like. Not sure why. I think we could see a lot more of the pufferfish effect if it was matte instead of showing the studio lighting in this like hyper gloss. What controls do we have for the pufferfish? We have the attractors here. I think that's it. I think you just input the facade comes in here. Like the voxels. And it produces that, so not more. Also kind of like bending inwards now. Or no, it just looks like it's very strange. Okay, but I want to move on, so I'm just gonna leave the strangeness for another time, and I will go back to the address. Because of course, you can go through this like for a while, but we've been working on this tower for a bit now, so I want to show you something new. Also, you can see there's an issue with adding components to an existing group. Okay. Use a Python component to call the OpenStreetMaps API and load the context for this model. It's placed at this address. Maybe if you open the Python file, maybe there are some interesting things you can change. It's actually super short. Calculates the interval. Yes, of course I can. I'll save the file in the same drive folder that I already shared a link to. So if you keep the link safe, I'll put the file there. So MetLife Stadium is our address. It's getting fed into the context fetcher. Not sure that it's good enough for context to be fetched. Then we get a radius. So from that position, how large of a radius do we want to draw in the context? And then there's a fetch true toggle here, but Raven's still fixing the Python file. Quite a strange tower. I can probably upload it right now. Current state. So might do an update later. Yeah. Okay, Raven thinks that this successfully ran, but actually it didn't load, I think, at least. Load anything yet. In this session, Raven is constantly zooming in on the part that it's working on for no reason. I think it's just because it was doing it at the start. Is there a way to keep the uploaded image in the file, the Raven session? So Raven still has a context of everything that you talked about. So these images are still in there. You have to save it locally if you want to use it in a new chat, though. What's up here? So it's loading something, but it's not. No. Raven's still fixing the. Once you have a node like this that works, like a Python file, then you can just reuse it and change the address. Just now I am making it from scratch, so Raven's struggling a little bit, but I think it will get it. Curious why it's struggling so much. Huh? Too many requests. Some issue with the OpenStreetMaps API. There we go. Hey, we got it. Okay, so this is the context, which I guess means that here in the center would be the stadium. So I'm just going to increase the radius for the context to maybe 2000, so 2 kilometers. And now if I update this, it will reload it again. So if we did this for, let's say, Manhattan, you would see a lot more buildings show up. But in this case, maybe timeout, okay. Maybe that's too much. Here we go. See, here's the context. We're in the middle of the stadium. Now, you can go way further. You can say, I also want roads, because those are also on OpenStreetMaps. I want the center line, or I want them with the width or anything like this. Say, actually, load instead load the Empire State Building address. And we'll get a very different context for our building. And it should just update the address, actually, whatever the address is. What? Oh, you have not? I'll just do it. So it gave me the right address, right? There we are. So now we have Manhattan. But unfortunately, our tower is also hidden behind it. So I'm going to change the alpha onto this. And then we can see how small our tower actually is compared to the Empire State Building. Here it is. Right there. Okay, I'll leave it here with the tower and show you one more thing that's a little bit more, it's a short demo, but it goes into plugins. It's kind of cool. We can use a context profile. Yeah, so if you got bored by the tower, now we'll do something else. I saved the file for you, Walter, no worries. In the folder I shared with you, there's one other image, and this is the Freie Auto Musik Pavillon. Freie Auto is a very famous architect and structural engineer from Germany. He did really cool, physics-informed structures, hanging chain models, soap bubble models. Very famously, actually, his designs for the Stuttgart new train station. Stuttgart is just being built at the moment. Has been being built for a while, but it's going to open soon. Very, very cool work. So I'm just using a very simple one of his images, which is this Musik Pavillon, because it's a tensile structure. And tensile structures are interesting because you can do them with Kangaroo. So you get everything else out of the way because I'm going to take a screenshot. Okay. So you can take the image that I sent you and you can open that in Raven, or you can, of course, also just copy paste like I am doing right now. And I will just ask Raven to, actually what I'm going to do is I'm going to open up the settings and go to the Kangaroo 2 profile. So now, actually, if I close settings again, you see down here, it says profile Kangaroo 2. So I know that I have a context profile active, which means I have Raven with additional information about how Kangaroo 2 works. Perfect. So we can just say, make a simple tensile structure and simulation of this Musik Pavilion. It's a very, very easy geometry, right? It's just 4 point surface. 2 are up, have high points, 2 have low ones. And then it's a tensile structure, so it's basically a piece of fabric that you pull. But I like it a lot. And with Kangaroo, you can make really interesting things like this. And Raven's getting to work, making a plan. Right now, he knows all about Kangaroo. So he can make this model with the Kangaroo in mind. Yash Rathod was asking about Ladybug. So Raven totally works with Ladybug. So you can try to make Ladybug scripts from scratch. There's a profile for Ladybug, so you can activate the context profile, or you can just use existing Ladybug files and ask questions about them and use them and so on. Actually very popular with Ladybug. You can also use Karamba. The issue is that I'm on my Mac and I don't have Karamba on my Mac, so I can unfortunately not do a Karamba demo. So we have the basic structure. Raven got it right the first try, which is great. Let's see if it already set up a simulation. Yes, okay, we have a simulation. That's great. Now it's running the simulation. See, it just set the toggle to true. And what I'm interested in is the length factor. So here, okay, so we're still previewing the unsimulated one. So I'm gonna select a bunch of things here and turn off the preview. So we should only see the results of the simulation. And there we go. You can see if I make the fabric stretch, then it kind of changes. But I can also already see Raven is anchoring all of the boundary points. But I don't want that. I don't want all the boundary points. I only wanted to anchor the 4 base points, which is using also here at the start. So now I'm just going to actually make my own changes to Raven's file. To do that, I will stop Raven. And I will delete the boundary anchors. And instead, I want to collect all these points and anchor those, and then reset the simulation. Ooh, okay, this will be fine. That should be fine. That should be fine. Let's accept the Raven's changes, and then tension factor. Okay, it's made map. Somehow, I guess. Okay, turn off the simulation. I somehow messed up Why did this mess it up? Okay, A, B, C, and D. I'm just going to use a merge so that we have the same order of anchor points as we have A, B, C, D anchor points. Flatten them. No? The mesh tension. Okay. I wanted to, so I'm stuck, so I'm just going to ask Raven. Wanted to anchor the four corner points, but now the surface is broken. Let's see. Maybe it's something to do with tri-mesh. It's not the surface I wanted. I think no. Okay. I need to change the order of these. Okay. Anchor 1, mast 1, anchor 2, mast 2. How's that look? And then anchor 1, mast 1, anchor 2, mast 2. Looks better, but it's not it. Huh. No. Use these. Well, okay. I'm just gonna actually, instead of doing anything here, I'll just rerun my initial prompts. Okay. Get rid of everything. Let's try again because Moritz messed up the perfectly good Raven script. And we can play with that. We can make interesting things. Once we have the tensor structure set up, simulation set up, we can make different shapes, combine fabrics together. So now the image actually disappeared here, but Raven can still see it. Here it comes back with almost the same script. This time it's actually just anchoring it exactly how I wanted to on the anchor points, on the corner points. So it's perfect. Let's run the simulation. There we go. Beautiful. Even better than last time. See? Now it actually looks like a tensile structure, so like a fabric that is under a lot of tension. Maybe more tension than we wanted to. Raven keeps going. He's thinking about visualization, but I'm going to stop him. That's fine, and I will undo the last edit. Here we go. And I want to control. So this is me now, collaborating with Raven because I'm no longer just like demoing one-off things, but I actually want to do things. So I will add sometimes I want to add my own slider. I'm not relying on Raven for everything. Okay, cool. So you can see if I make the fabric more tense by reducing the length of each mesh edge or increasing it, you can see shape change. And now what I'm interested in is so let's see how that goes. If we ask Raven to add more of these, so like this. Okay, it's getting a bit out of hand. Like this, like this, like this, like this. Connected, connected here, connected here, connected here, connected here. Can you make 4 of them in a pattern like this and connect them at the indicated edge points? So we can build a larger structure. And then we can also say, okay, let's basically sew them together. So instead of keeping the gaps, in the next step, we can say, okay, we've connected them at the edge points. What would it look like if we connected them all along the edge? Not anchor them in space, but keep them connected to each other. Or have them pull towards each other. Like, you can do interesting fabric simulations like this. Ooh, look at that. Fun. I'm having a blast. Okay. Yeah, so here we have our tent structure. It actually already sewed them together. It looks like it. So now if we put a lot more tension, more tension on this. Yeah, reset the simulation. Nice. You can turn off those point previews. Look at this. Very cool tent structure. And I can say add the columns that hold at the mass. Mass as simple cubes in black. But I'll wait for him to finish his whatever he's trying to do. Actually, no. Just accept it and then undo. Perfect. Take off some of that stretch. Add the mass in black. Actually, I think this is the shape that the structure has. So the mass will come in here. But if you flip it, then it becomes like a tent structure. Uh-huh. Here they are. Not quite in the right position. Some of them are. Some of them are not. It's the wrong number that he has here. I'll fix it. Oh. Looks like this edit script was a bad idea, so I'm going to stop him. Nice. Now we have a structure with the mass. And it's still simulated, so course, we can adjust it. Now, Raven actually used all these construct point components, which I don't really like. So I'll ask him to please replace these construct point components with param point components. They'll be easier to adjust. Depending on what you want to adjust. If you just want to increase the Z height or something, these are actually better. But the other ones you can click in the scene and move them. Here we go. That's perfect. So now I can pick one of the points. Ooh, okay, the order is messed up again. That's really a thing with these. But in theory, you can now move. Okay, I'm gonna undo that. Yeah. Anyway, that was my kangaroo demo. Now, if you guys have any other things you want to see, otherwise, I'm also happy to take some of your questions. There's more that you're interested in seeing. I think we've seen the kangaroo demo now. Also just checking how many people are still with us. Still 50 people, pretty good. Raven should work fine on Rhino 7, but it doesn't support Python 3. Okay, yeah. Maybe some of you guys also just want to tell me about your experience if you've been using Raven throughout this workshop, because it's a very one-way street. So I don't see usually when we do workshops in person, I can walk around and I can see what people are doing. So I don't know, just let me know if you had some good or bad experiences. Do other people work on cat prompting tools? Yes, I probably, but you probably have to wait another 3 years or something. We use different LLMs, but we don't have our own base LLM. So we have we have some of our own ML, machine learning logic, and we have different LLMs that we switch out depending on different parts of the system. So it's like a whole system. I'm glad you like it.
We can see if anyone does want to share what they did or anything. I can promote them to panelists if anyone's interested to do that. Just maybe raise your hand.
So Mohammed, if it didn't work for you to do the kangaroo thing, make sure you are in the context profile for kangaroo and using the smart mode. That should fix it. So if it didn't work for you, maybe the setup wasn't quite the same. So it looks like somebody is volunteering.
Huda, you want to show your screen? Is that what I would like? Is that what you mean? Huda?
I mean, if not, that's also okay. But I'd be curious to know.
We have one here. Okay, let's see. Where are you? There you are. Two. Okay, let's go with I think Yash was first one. So let's just promote to panelist. I'll bring them both. Promote, promote.
Hi, Ash.
Hi. Thank you for the workshop. This was really good. I'll quickly share my screen. Okay. So I was trying to follow
Nice.
the voxel tower, try to create the context as well. It's fun. Also, I wanted to play with the areas so that I get the flow plates. And then I was curious that if I change the height, then how it would react. So there's this organic play also. So that's fun.
Cool. Super cool. Awesome. Thanks for sharing. I'm glad you followed along and got a good result.
Yeah.
Yeah, nice one.
Can you hear me?
Yes.
Hey, Vijay.
Yeah, hi. So I didn't try a lot of stuff, but I was basically trying to create a way in which I can use multiple facades for stream work. Can you see my screen?
Yeah.
Yeah. And so basically I can choose what type of facade patterns I want. And right now I'm trying to I'm trying to create a framework behind it, and I can do an analysis using Karamba for that. Yeah. I think it's working on that. So I saw that you used Karamba for some of the simulations in your tutorials. So like if you could just highlight some of the components that you played around with to do that.
Basically, I used an existing Karamba script and then just opened up Raven and then just had a discussion about the Karamba script, and Raven could change things. Like it could, pick a different beam from the available beams in Karamba, and so on, and just have a conversation about the script. Yeah. So
Yep.
I wasn't making it from
Yeah.
scratch, actually.
Okay. Interesting. I'll stop sharing.
Yeah, it looks nice though. Thanks for showing.
Thanks. Yeah.
Cool.
Thanks. Anyone else wants to show what they're doing?
So I'm just going to answer questions that pop in the chat. So Arian is asking if you can encode like basic levels of city code in Raven. And so basically what you would do for that is create a context profile. So you can create your own version of it. It doesn't need to be for plugins. It could be for example, for your New York City massing. And there you can just list facts or things Raven should know. And then you set it into the mode. It can be your private context profile. That's just like your own specific context of massing apartments, buildings in New York City, and you can activate the context. And as you work with Raven, it knows those things, so you don't have to like prompt it every time. Basically, that's how you would use the context profile in that context.
Well, I guess if no one has any more questions or wants to show, I guess we can call it over.
All right.
Yeah, thank you so much. It was really awesome for giving us a glimpse into the future of the way we'll all be working very shortly. Yeah, thanks for taking on that endeavor and in making one of these things for all of us to use.
Of course. Thank you for inviting. Yeah, great to engage with the community and like, you know, see what people do. And I hope you feel empowered and it helps you achieve great things.
Yeah, so thanks everyone. We'll just remember that afterwards you'll get an email to watch the recording. And then even after that, eventually we'll go on to our YouTube. So make sure you subscribe to our YouTube if you want to get notified when it goes to YouTube. Thanks again, everyone who stayed for the entire thing, and thanks especially Moritz.
All right, thanks, Michael. Thanks, everyone. I had a
Thank
great
you. Bye.